All right, today's video is a short one. It's just going to be a summary of all of we've learned so far in terms of ionic compounds, whether it's binary or ternary. There's going to be some transition metals in here. There's also going to be some covalent compounds in here as well. So I just want to go through my thought process with you when I see a problem and when I'm trying to name it. So for example, here on example 6, letter A, I see MgCl2, and the first thing I think is it ionic or is it covalent? Okay, and so that's a really, whether it's one A through H or I through P, it really matters. What really matters here is it ionic or is it covalent? So on A, that's the first thing that I think is it ionic or is it covalent? And I see that magnesium there in the front, and I go, oh, it has to be ionic, because ionic contains metals and nonmetals, or positive charges and negative charges. So I know it's ionic. So since I know it's ionic, I know that I don't use prefixes when I write the name. So that 2 after the chlorine, that doesn't have any bearing on when I write the name of it. Okay, and now that I know it's ionic, I ask myself, does it need a Roman numeral or not? If it doesn't, which then I just write the name. If it does, then I have to figure out what that Roman numeral is. Magnesium is in the second column. It's always a +2 charge. Its charge never changes. So in terms of writing the formula, it is just magnesium chloride. Okay, letter B. Again, first thing I think, is it ionic or is it covalent? I see that nitrogen and then the Cl3, so those are 2 nonmetals. So since they're 2 nonmetals, I know that it is covalent. And since it's covalent, I do have to use prefixes. So N is nitrogen. And then chlorine's going to become chloride, but there's 3 of them. So it's going to be nitrogen trichloride. So again, notice on A, I didn't use a prefix. I didn't put dichloride, but on the second one I did, because again, on ionic compounds, A, right, this one's ionic, this one's covalent. On ionic compounds, the reason that 2 is there is because magnesium has a +2 charge, and that +2 charge has to go down to the chlorine. So we don't need to say magnesium dichloride, because the 2 is there because of the charges, not because of some prefixes. Okay, whereas with nitrogen and chlorine, there's lots of different ways that nitrogen and chlorine can combine. So that's why we need that prefix there. Okay, letter C. This is the only tricky one that's ionic that might appear to be covalent, okay? Because I see that nitrogen, I think, oh, covalent. But then I remember, oh, NH4, that's a positively charged ion. And that's the only time that's going to happen to you in this class is with ammonium. Okay, so NH4 is NH4 plus and then Cl minus. So that is an ionic compound. So again, with ionic compounds, I just state the name. So that is just ammonium. And again, no prefixes. So no monochloride there because it's ionic. Okay, and then back to covalent here. You've got carbon and chlorine. Those are both nonmetals. So this is carbon. And then 4 is tetrachloride. And then letter E, you've got a metal with nonmetals, so that one is ionic. So Na is sodium. And ClO3, I look at my ion sheet, ClO3 is called chlorate. Okay, so that is called sodium chlorate. Okay, and so far, yes, we've had a few ionic, but we haven't had any that are in that transition metal area. So letter F, we're finally there. This is an ionic compound. It's got a metal with nonmetals. Cu is the chemical symbol for copper. And HCO3 minus, again, anytime there's more than one nonmetal group together like that after the metal, you're looking at that list of ions that I gave you. So HCO3 minus is called bicarbonate. And I leave a little space there in the middle. because I know I need a Roman numeral. Okay, and so I really need to know what's the charge on bicarbonate. So I go and look at the ions that were given to me. Bicarbonate does have a -1 charge. So therefore, since there's only one bicarbonate, that means the copper has to be +1. So this is copper 1 bicarbonate. Okay, letter G, again, ionic or covalent, right away, that's the first thing you think about. Calcium's a metal. It's on the left-hand side of the periodic table, so it's a metal. It does not need a Roman numeral because calcium's always +2. So this is just called calcium phosphide. Okay, and then our final one is also ionic. Cobalt is a metal. Okay, and it is a transition metal, so we're going to need a Roman numeral. So this is cobalt, and then PO4 is called phosphate. Now we just need to figure out the Roman numeral. So phosphate has a -3 charge, and there's 2 of them, so that's -6 all total. Again, notice how I did that. I looked at PO4 on my list. It has a -3 charge, and then I thought, oh, there's 2 PO4s, so that's a -6 charge all total. That means cobalt has to be +6, and +6 divided by the 3 cobalts is 2. Okay, and remember, another way you can do this, guys, is oftentimes it's really easy just to take these numbers and put them back up here. So notice that this 2 from the phosphate could just come back up here, and that's the charge on the cobalt. Okay, over on the right-hand side, we're going to write the chemical formula. So again, ionic or covalent. And again, usually with covalent ones, you'll see some of these prefixes here, and that will help you. Oh, that one has to be covalent. The other ones are going to be ionic. Okay, so for I, we've got barium. Barium has a +2 charge. Hydroxide has a -1 charge, so that one is ionic, of course. So we have to switch those charges. So this 2 is going to come down here. So we're going to get barium. And then don't forget about those parentheses on the OH. And then we have OH parentheses 2 is the correct formula. Okay, letter J, dinitrogen. It means that there are 2 nitrogens. And then pentafluoride, so that's fluorine. And penta means 5. That's all there is to those covalent ones. Okay, letter K, iron 3 acetate tells you that iron has a +3 charge. And then if I remember acetate, great. If not, I go and look at it in my notes. It's C2H3O2-. And then I take those charges and I switch them. So that's going to be Fe, and then in parentheses, C2H3O2. And then that 3 needs to go outside of it. Okay, letter L, aluminum sulfate. Remember, aluminum is in that transition metal area, but it does always have a charge of +3. And sulfate is SO4 2-, and we take those 2 and we're going to switch them again. So Al2, and then we need SO4 in parentheses. And then we're going to put the 3 from the aluminum outside of it. Okay, letter M, we've got tricarbon, so carbon 3. Nana, bromide is bromine, and nana is the prefix for 9. So C3Br9 is what that would be. Okay, letter N, phosphorus monochloride. So phosphorus, there's no prefix in front of it, so that means 1 phosphorus. And then chloride is Cl, and it's mono, so we just need 1, so it is just PCl. Okay, letter O, vanadium 5 means that vanadium has a +5 charge. Oxide is O, that has a -2 charge. So again, like always, we just switch those 2, and we get V2O5. And then our final one, silicon triiodide. Silicon is Si. And then iodide comes from iodine. So that's I, and with a tri, that means there are 3 iodines. Okay, so hopefully that kind of gave you a little bit more clarity about ionic versus covalent when you name them, when you write the chemical formulas. when you use prefixes, when you don't use prefixes, etc.